We're going to use the TAS Systems Project Wizard to quickly create simple airside and plant room systems. We begin by importing TSD data, which contains room loads from our TBD simulation. We can assign zones and zone groups to different airside systems. On the next page, we'll choose the system types. The system types are chosen from a drop-down list of pre-made systems. For this example, we'll stick with a familiar fan coil setup. We have the option here to change fan and exchanger efficiencies, as well as some other details about the systems. These can also be changed once the wizard has generated the systems. The loads from the airside systems will be passed to the plant room via collections. Here we choose a plant system to handle the heating loads. In this case, we'll choose a system where one boiler serves the heating and domestic hot water loads, including a hot water tank. We assign the heating loads to the circuits. This is the boiler editor. Once again, we can set efficiencies here in the wizard or through the user interface once the systems have been created. On the next pages, we select plant systems to handle the loads from our cooling collections and domestic hot water collections. We can add PV and solar hot water panels or wind turbines to our project. We assign fuel sources to the different elements of our plant room. In this case, natural gas for the boiler and grid supplied electricity for the chiller, fans and pumps. To size the equipment, we can use design conditions from our TBD file or create dynamic design conditions here. We will size our components over our whole year simulation. The wizard generates the systems, which are ready to simulate straight away. But before we do that, let's take a quick look at what was created. Here we have an extract-only system. This is a very simple airside system consisting of a fan and a zone with a radiator. This is our fan coil system. We have 18 zones sharing a common supply and extract. There is a fan coil unit within each zone. The air handling unit includes heating and cooling coils, as well as a heat exchanger. We can click on any component and edit its properties to change how the system operates. System operation can also be regulated by controllers, which convert parameters such as air temperature into a signal to be passed to a component. In the plant room, we find our waterside systems and collections. Here are our heating, domestic hot water and cooling collections, and electrical collections for lighting, fans and equipment. The waterside systems work along many of the same principles as the airside systems, including the use of controllers and the ability to edit component properties. Airside and waterside systems created by the wizard can be edited by dragging in components from the library. But rather than edit our plant room in this way, let's simulate what we already have. The simulation is based on the room loads taken from our TSD file, but takes into account air loads added in this file. Once equipment has been sized using the design condition we specified, our final results are generated in the annual simulation. For every hour, the airside systems are simulated to provide loads for the collections, which are then handled in our plant room simulation. Any issues encountered during simulation, such as unmet hours, are reported here. Results for individual components can be seen in tabular form or in a graph. And results for the whole energy centre can be viewed in charts.